So bar charts. Here's yet another new data set. Okay, so here's a list of, or a table consisting of 200 movies. The top movies in terms of their adjusted gross. So we have the movie title, which we've set as the index. We have the studio that released the movie, the gross, how much money the movie made, the adjusted gross, meaning adjusted for inflation, since some of these movies were released a long time ago, and then the year that the movie was released. So how many top movies has each studio released? Which studio is sort of the most successful? So to do this sounds like a group by. Remember, I'm using the word each here, so that kind of tips me off that I'm going to use group by. So I take my table, I group it by the studio, and then I count how many rows I have for each studio. So let's see what we get after that. Okay, so what I have here is, remember, I'm grouping by studio. So for each studio, I get a miniature table that is consists of the movies released by that studio, the top movies. And what I want to do is I count how big that table is, how many rows it has. Here's what I get. And if I just want, a series of counts, I just want one of these columns, I'll get any one of them. So I could get, for example, the year. So now I have the number of top movies released by each studio. Now I'm going to put this back into a table that I'm calling count. I'm using the assign method to do this. Okay. You might remember if I just wanted a table out of this, I could have put year here in square brackets. And what I get back is not a series, but actually a table. Okay. In any case, I have a table now called count. And what it looks like is this. Okay, so I have as its index the studio, and as the column, the count of top movies each studio has released. So I want to make a chart that visualizes this, and the natural choice here is a bar chart. So if I make this plot, here's what I see. On one axis, I have the movie or the studio name, and then on the other axis, I have a bar whose length encodes the count, the total number of movies that studio has released, the total number of top movies. So the height of the bars, in terms of this height, vertical height here, is arbitrary. What we have here is what you might call a horizontal bar chart. A lot of times you see bar charts rotated, and so the bars are going from top to bottom. But it makes a lot of sense to plot them horizontally like this, especially if you have long labels like Paramount DreamWorks. This way of plotting the bar chart is nicer so that the labels don't overlap. So here the vertical size of the bar is meaningless. It's totally arbitrary. The spacing between the bars, also arbitrary. But what means something, of course, is the length of the bar, or the width, if you will, from left to right. In this case, I have only one numerical variable, and that is the number of movies released. The other variable is categorical. It's the studio. Okay. The order of the vertical variables here is arbitrary. Though in a second, I'm going to want to make it not arbitrary, and I can do that. Now let me point something out here. So I'm calling the plot method with kind equals bar h. The h stands for horizontal, so horizontal bar chart. I'm omitting the x keyword argument because I'm just using the index here. Remember, the index of my table is the studio name, and then the y-axis is count. Now, what's a little confusing here, perhaps, is that I said y equals count, but notice that the counts appear on the x-axis. Okay, in some sense, this is a annoyingness with pandas. Perhaps this shouldn't be called y equals. Maybe this should be the dependent variable. So I have the independent variable and the dependent variable, and the y is the dependent variable here. Just anytime you write x equals, you're saying this is the independent variable. Anytime you say y equals, you're saying this is the dependent variable. All right. So let's make this visualization slightly nicer. One thing is that, these bars are just sort of in a haphazard, arbitrary order. It'd be nicer if we sorted them by their length. Let's go ahead and do that. What I'll do is I will first sort the values, or sort the rows of the table by the count column. Then I will plot it. So if I do that, this is what I get. So the largest bars appear first. And of course, if I sorted this in a different order, so ascending equals false, you see that I get it in this order. What's interesting is that, right? So I've used ascending equals false, which means that it's sorted in descending order. But it depends on how you look at this plot, because it looks like the bars are plotted in ascending order of length if you look at it this way. But the way Python is looking at it is this is the first bar, Warner Brothers, and you're going up. So in this sense, we are going in descending order. Just another thing to kind of remember, but not crucial. You don't have to memorize this ability. You just have to remember that I can either sort ascending or descending here, and that will change the way that the bars appear. I've also made the plot slightly bigger. I've done that with this fig size keyword argument. And what I do here is I say fig size equals and then give it a pair of numbers which describe how narrow and how wide the figure should be. So we've seen horizontal bar charts, and I argued that usually horizontal bar charts are kind of better, but we can also make vertical bar charts if we just use the if we just use the bar kind instead of bar H. So here's what we get. And here, Pandas is helpfully automatically rotated the labels so that they don't overlap, which is fantastic, but they're kind of hard to read now. You kind of have to tilt your head and read long things like Paramount DreamWorks. So I kind of suggest horizontal bar charts, but you can choose whichever is appropriate for the particular setting. So let's stop for a second and kind of think about this question. I'm going to run this code down here. What am I going to get? I'll give you a second to think about it. You can go ahead and pause the video if you want to take more time to think about it, but I'm going to go ahead and describe the answer. So it helps to take a look at this chunk of code, which here we're doing a ton of method chaining, and break it down piece by piece. So we're going to start with how Python reads this, starting from left to right. So we start with our table of top movies, and we assign it a new column, which we're calling age, and we're computing it by taking the current year, so 2020, and subtracting the year in which every movie in the dataset was released. What we're getting here is the age of the movie in number of years. That's why we're calling this the age column. So we assign that back to the table in a column called age. So now we have a table with a new column called age. We group by the age, and then we apply the count aggregator. So what I'm doing here is I'm grouping all of the rows of the table by the age. So remember, a row in the table here is a single movie. So I'm grouping all of the movies by their age. I have a group of movies that were released 5 years ago, a group that were released 6 years ago, and so forth. Now I'm counting the number of rows within each group. So what I get back here is a table where the index is the age. So the row labels are the ages. And then in every column, I have the number of movies of that age. Okay. Then I plot, I make a bar chart. What might throw people off, it threw me off whenever I reviewed this question, was I have y equals studio here. So am I plotting something to do with the studio? The answer is no. Let's remove this code for a second and see what we get after this. Remember, I have a bunch of columns. All of them are going to have the same information. It's the number of movies released which have this age. Okay. Now, these column labels, remember whenever I do group by and then I do an aggregation, the column labels kind of no longer make sense. All I'm doing is I'm counting how many entries were in the studio column, how many were in the gross column, and so forth. So if I ask for the studio column, it's still giving me the same information as if I asked for what's in the gross column, what's in the year column. It's the number of movies. So that's what's happening whenever I use y equals studio. It has nothing to do with the studio per se, it's the number of movies of that age. So now I make the bar chart. What I get is a bar for every age in the data set and counting how many movies were released with that, which have this age. So this is what we get. We get a bar for each age, okay, and its length is the number of movies of that age. The answer is B. So let's ask a couple more questions here. Which Star Wars movie was most successful according to adjusted gross? Now to do this, I need to select all rows whose labels contain Star Wars. Now when I say contain, I mean like it's part of the title. We don't know how to do this quite yet. There's a trick in pandas. It's a very helpful, useful feature of baby pandas and pandas as well. I can use .string.contains. So remember here in top movies, I've got the index. Let's just take a look at the table overall. The index consists of movie titles. I want to pull out all of the rows which have Star Wars in the movie title as part of it. So what I do is I get the index. Now I can't just say equals Star Wars. Star Wars. Okay. If I do that, I get false for everything because none of the movie titles are exactly equal to Star Wars. Okay. So I do this kind of special thing. I use .string.contains. And then I say, what should it contain? I say Star Wars. And there I get trues where some of the movies, where the movie title contains the phrase Star Wars. And this is a Boolean array. I can use it to do a query. I can select the rows of the table. So this also works on columns. So for example, if I want studios, so let's get the studio column. So I've got all the studios. I want the studios which contain Disney, because some of them are different. I might have Disney, I might have Buena Vista Disney. I can still do .string.contains and say Disney. And then I get a Boolean array back, or a Boolean series in this case. And then I take that Boolean series and I throw it back into the table, and it returns all of the rows for which the studio contains Disney. So let's answer our question. Which Star Wars movie was the most successful? So I find all of the Star Wars movies, and I do that this way. I do topmovies.index string contains Star Wars. I throw that back into the table, and I get a table with the rows, whose rows are just the Star Wars movies. And then I plot a bar chart with the adjusted gross as the dependent variable. And so here's what I see. According to adjusted gross, the first Star Wars movie was the most successful.